Good evening, one and all. Our project is sentiment analysis of Russia's invasion of Ukraine. We are pleased to present our project in front of you. We would like to thank Dr. Tony Diana for his encouragement and guidance to complete this project successfully. Before we start with the project presentation, let me introduce you to my team Ajit, Shrishti, and Shri. And I would like to introduce myself as well. I am Karan Pise, and we will take you through our project sentiment analysis of Russia's invasion of Ukraine. During the presentation, we'll go through the following content. Let's have a look at the introduction at about what sentiment analysis is. Sentiment analysis is a machine learning tool that analyzes text for polarity between positive to negative. By machine learning tools with examples of emotions in text, machine automatically learns how to detect sentiment without human input. Sentiment analysis is widely used by companies like Intel, Twitter, and IBM to determine employee concerns. Additionally, sentiment analysis is being used for market research, brand monitoring, etc. Now let's go to the next slide. From here on, further slides will be explained by Ajit.
Hello friends, now I'll take you over the hypothesis and approach of our project. The hypothesis of our project is that the overall sentiment of people around the globe will be negative. And these are some of the questions which we have tried to answer through this project. First, what are the effects of the invasion on the sentiments of the people around the world? Second, what are the sentiments before the invasion happened and after the invasion happened? An approach for the project has been following. We have carried out a sentiment analysis of Twitter data and Google News data. In the case of Google News, we have carried out sentiment analysis of two timelines. Along with this, we have analyzed country-wise data. Now, let's move ahead and take a look at the data sets. As I said in the previous slide, we have two data sets. One is Twitter data and the other is Google News data. We have divided the Google News data into three parts. One is before the invasion to track the sentiments before the invasion happened. The before invasion timeline is from November 2021 to Feb 2022, which is a period of just over 3 months. The second is after invasion. The after invasion timeline is from February to May 2022. The third is country-wise data for the following four countries: the United States of America, Canada, India, and the United Kingdom. We have selected these countries because out of the four, the United States of America and the United Kingdom are two countries that have sternly sanctioned Russia. India, because it has close business ties with Russia, and those influenced India's decision making in terms of replying to the global calls to impose sanctions on Russia. And the reason for selecting Canada was because of the support offered by Canada to Ukraine and its citizens. Now we'll move on to the next slide. The Twitter data has been extracted using Twitter API. We have extracted and saved over 300,000 tweets related to keywords based on Russia's invasion of Ukraine in a CSV file. In the case of Google News data, the data has been extracted using PyGoogle News library.
Hi guys, I'm Shri. So now we'll be discussing about the methodology of our project. Our methodology has been divided into four parts: data processing, EDA, sentiment analysis, and machine learning models. As we can see from the representation, for creating both the data sets, we have gathered the data using the Twitter API for the tweets and PyGoogle News library for fetching the news from Google. We have scraped, cleaned the data, and did exploratory data analysis on the generated datasets. Moving further ahead, we have analyzed the sentiments of tweets on Twitter and the news for about past 6 months, starting from the month of November. For sentiment analysis, we have performed several methods on the data like tokenization, removing stop words, lemmatization, and sentiment labeling. After that, we have made use of machine learning libraries like decision tree classifier, bridge classifier, and few more to get the best accuracy. Now Karan will explain the EDA code.
EDA, Exploratory Data Analysis. In this slide, we can see the top 10 locations with most tweets. As we can see, most of the tweets are from Ukraine, followed by United States of America, followed by India, and then the other countries. Based on the top 10 countries, the word cloud on the left shows the most used words in the tweets, and the word cloud on the right, we can see, we can find the most words used in the Google News. Moving to our next topic, sentiment analysis.
The workflow of Twitter and Google News sentiment analysis can be seen in the representation below. In the first step, as discussed earlier, we have fetched the data using the API and the Google News library. Then we clean the data by removing punctuations, hashtags, emojis, and limit the language to English, as a large amount of data was in English. In the next step, we have preprocessed the data by removing stop words and tokenized the data using the text blob library, which means that the sentences extracted from the tweets are collected and then split into tokens, each of which consists of a single word. We have lemmatized the data using the Snorkel library to reach the original forms of the text present in the data. After that, we have performed sentiment labeling by labeling -1 as neutral, 0 as negative, and 1 as positive. Then the pre-processed data has been used to create a classification model. Below are the results of the sentiment analysis. As we can see, surprisingly, there are more neutral tweets than negative. This can be attributed to the fact that the dataset contains tweets from all across the world, which includes people who are directly not affected by the invasion. For the news analysis, we have labeled before invasion data and after invasion data and the data of the combined country. In case if before invasion data and after invasion data, we can observe similar results and that the majority sentiment is negative, followed by neutral, then positive. For the combined countries dataset, as it contains the countries which have different levels of relations with Russia and Ukraine, we have observed that the majority sentiment is neutral to that of Twitter. Now, Karan will explain naive Bayes.
For our project, we have used 3 machine learning approaches. The baseline model is the naive Bayes model. Then we have implemented pipelines, and then we have used the transformer, and we have implemented the BERT model in the transformer. Naive Bayes model. So based on our initial research, we found that the naive Bayes model is the best choice for the text classification. So what is naive Bayes model? As we all know, naive Bayes is the simplest and the fastest classification algorithm for large chunks of data. It uses the Bayes probability theorem for unknown class prediction. As we are aware of the fact that naive Bayes classification technique is one of the most simplest and the most powerful classification algorithm in machine learning. The use of Bayes theorem with a strong independent assumption between the feature is the foundation of naive Bayes classification. When used for textual and data analysis, such as natural language processing, the naive Bayes classification yields optimal results. We have used naive Bayes as our baseline model to determine the accuracy of the data based on model training. As we can see in the classification reports, we got 86% accuracy for the Twitter dataset and around 84% accuracy for the Google News dataset. The further slides will be explained by Srishti.
After implementing the baseline model, we use the lazy predict method to get the accuracy of the top 6 models for our datasets. As a result, decision tree classifier, random forest classifier, AdaBoost classifier, rich classifier, logistic regression, and SVC models gave the best accuracy among all other models. Now, next step for model training was to implement a pipeline using the 6 models we got from the lazy predict method. After data acquisition, as you can see in the pipeline and text pre-processing, we have built a pipeline of 6 models as mentioned in the slide. For model training, we have split the data with a ratio of 80% as training data and 20% is test data. After execution of the pipeline, we found that the rich classifier gave the best accuracy of 89% for the Twitter dataset And decision tree classifier outperformed with the accuracy of 87% for the Google News dataset. Here we have a comparison of ML models for both the datasets which we have used for the pipelines. Now, to further analyze the data, we delve into the deep learning approach as well using TensorFlow and Keras to determine the accuracy but could not get better results. The accuracy was only 65%. Hence, the classification models performed well as compared to the deep learning approach. At last, we tried using transformer in order to further improve the accuracy percentage. We have used the BERT model to analyze the sentiments. Now, what is BERT? BERT, which means bidirectional encoder representation for transformer. It is an NLP model developed by Google Research in 2018. BERT is designed to help computers understand the meaning of ambiguous language in the text by using surrounding text to establish context. The BERT framework was pre-trained using text from Wikipedia and can be fine-tuned with a question and answer datasets. Now, as we already know, transformer architecture has an encoder and decoder stack. BERT is just an encoder stack of transformer architecture. BERT model is also divided into two categories as BERT base and BERT large based on the layered complexity. In our analysis, we have used the BERT base model. Now, why we have used the BERT? As BERT is a bidirectional model, it tries to look from both directions, left, right, and right, left. To predict a masked word, BERT takes both the next token and previous token of the masked word into the consideration for the prediction. Here is the classification and confusion matrix report of the BERT model which we have achieved after model training. So as we can see, BERT gave the optimal accuracy of 97% with 4 epochs and a batch size was of 32. Now, Ajit will take about the conclusion and applications.
Hi friends, now I'll talk about the conclusions and the applications. As Twitter data and Google News includes users from all over the world who are not directly affected by the war, we find that a high number of tweets fall under the neutral category. For Google News, before invasion and after invasion, the overall sentiment was negative, and for the combined data of 4 countries, we find that the result was neutral. In terms of applications, organizations can use this to plan out their future course of action, as well as Russia has been suspected of using this to spread disinformation and sway opinions online about the invasion. In terms of future work for further analysis, we can use the BERT transformer model in other sections of the data to acquire best accuracy. Also, we can use the upgraded version of BERT, which is Robert A, to train the model and calculate the accuracy. Thank you.